So I was reading some theories for the practical of designing 4-bit binary adder subtractor circuit using 7483 full adder. So there is the boxes. These are the 7483 full adder. There are 4 full adder for 4-bit full adder. So the main thing was that I was actually uh, evaluating the particular part of the full adder is this part. This is called overflow detection part of the full adder. So it actually detects of the carry in and the carry out of the sign bit. This is the sign bit, this is carry in carry out. So I was actually determining the various possible combinations for this input terminals. So this can be 0 0 0 1 1 0 and 1 1. In this book, the Mano's digital design book, Sarah only discussed two topics, two combinations. One is where 0 1 and 1 0. In this particular scenario, it's 0 1. The carry in is 0, carry out is 1. So this is 1 0 basically. Carry out is 1, carry in is 0 in this particular example. In this particular example, the carry out is 0 but carry in is 1. So here Sir discussed the only two out of four, only two possible combinations of the input 1 0 and 0 1. So this is when the output is 1. Output is 1, determining the overflow has happened. So shift the sign bit and evaluate based on the 8-bit magnitude. It's a part of the circuit, but the things that did not give us in this particular textbook, which is the rest of the two combination. One is 0 or 0, 0 or 0 and 1 or 1. So I have evaluated here all the four combinations and analyzed the most possible uh, combinations where such conditions may occur of 0 0 0 1, which is already discussed in the book, 1 0, which is again only also discussed in the book, and 1 1. And I have evaluated that in the 0 0 it's not that kind of interesting. It's only when the output is in range and both of them are positive, and one of them can also be negative. Here you can see one of them can also be negative, but the main result output should be positive. No, this is not the this is the main example. This is another example. So in this example you can see the negative second input is -7. So 0 0 condition of this particular part of the circuit in the v terminal in the overflow detection part, 0 0 may happen in both two scenarios. One is when there is simple two binary bits and getting added, but the output is in range, 7 is in range, the maximum possible for the 3-bit number. And and the second possible scenario where 0 0 may occur is this part where 3 minus 7 is happening here. So in the 3 minus 7, when we do in binary, the 0 or 0 or 0 is also getting reflected here. And 0 1 and 1 0 is already discussed in these particular two examples, but 1 1 was very interesting to me when I analyzed the all the possible examples that may occur, that may give a input terminals of carry in carry out as 1 and 1. It looks like that either when we do plus x minus x, I mean it can be plus 4 minus 4, it can be plus 2 minus 2. Ultimately we are saying that when the result is 0 of the uh, subtraction, you can say. So when the result is 0, this particular scenario will happen, 1 plus 1s or 1. So hence I wrote it in generalized time, plus x minus x. And yeah, because minus 0 does not exist in 2's complement. 2's complement form minus 0 does not exist. In 1's complement form it exists. And the second scenario, it is the most and super special case in the sense, because when we do subtraction of minus 4 and minus 4, ultimately we add them. So minus 4 and minus 4 is basically minus 8. So when you do it in binary with 2's complement form, we see that there is a overflow basically happening, but we ignore that overflow. We take this fourth bit as a sign bit and do the 2's complement. The fun thing is that 2's complement of these 4 bits, 1 0 0 0 is basically 1 0 0 0. There is no change in doing 2's complement here. So that for that particular reason, this is the only case where 2's complement does not change a series of binary signals, we can say signal, we can say values. So this is the particular and only one scenario where 2's complement does not change it, and making it a super special case where one is happening in the overflow detection circuit. And yeah, that's so cool. But yeah, that's all.